Hello, my name is Saif. Today's my topic is magnetic optical activity. Magnetic optical activity refers to the phenomenon where the optical properties of material change in the presence of magnetic field. This effect particularly interesting in the context of channel materials where the interaction between light and materials is affected by handedness of molecules. Key concept first is chirality. Chiral molecules are those that can't be superimposed on their mirror images. In magnetic field, the handedness of these molecules can influence how they interact with polarized light. Then optical activity. This is the ability of substance to rotate the plane of polarization of light. Optical activity is typically observed in chiral substances like certain organic compounds. Then magneto-optical effects. These effects arises when a magnetic field interact with electromagnetic field of lights. The well-known example is Faraday effect, where the plane of polarization of light is rotated in the presence of magnetic field along the direction of light propagation. Then applications. Magnetic optical activity has significant applications in fields such as material science, chemistry, and biology. It can be used for studying molecule structure and analyzing chiral drugs in the development of optical devices. Then we have Lorentz model. The Lorentz model, which explains the response of electrons in a medium to electromagnetic fields. Second one is Maxwell's equation. Governing equation for electromagnetism that can be incorporate magnetic field to describe magnetic optical activity. Then we have two type of techniques. First is ORD, optical rotatory dispersion, which measures how the rotation of polarized light changes with the wavelength. It depends on wavelength. Then magneto-optical Kerr effect, which is also used to observe the magnetic properties of materials through changes in polarization upon reflections. Then second topic, chemical aspect of enzyme action. Enzyme. Let's first talk about enzyme structure. First is structure, which is typically a protein with complex 3D structure. Their functionality is closely tied to their shape. Then enzymes have also a active site. Active site is a specific region where substrate binds. It has unique chemical environment that facilitate the conversion of substance into product, and this is the working area of enzyme. So mechanism of action. So we have two model, lock and key model and induced fit model. So let's talk about lock and key model. The enzyme active site, which which works like lock, is complementary in shape to the substance, which work as key, which allows specific binding, like you can see in diagram. Enzyme will bind into substrate in this shape. Then induce the fit model. The binding of substrate induced a control motional change in the enzyme, which will enhance the interaction and facility in the reaction. Then enzyme kinetics. Uh, First is Michaelis methane kinetics, which describe the rate of enzymatic reaction. It involves parameters like Vmax and Km. Vmax is maximum reaction rate and Km is substrate concentration at which the reaction rate is half of Vmax. Indirectly, enzyme affinity for the substrate. Then we have factors which affect the enzyme activities. First one is pH. Every enzyme has optimal pH range. Deviation can lead to denaturation or decreased activity. Then temperature. Every enzyme has its own optimal temperature. So if we give higher temperature than optimal temperature, it will lead into denaturing enzymes. And if we give low temperature, it will slow down the reaction. Then substrate concentration. Increase the substance concentration, typically interact reaction rate until the enzyme is saturated. Then cofactors. So cofactors are non-protein molecules. Their main role is to assist in enzyme activities. They are mainly like ions like magnesium and zinc. Coenzymes, they are organic molecules which are derived from vitamins like NAD plus FAD. Their main role is to assist in transferring chemical groups during reactions. So in the conclusion, the understanding the chemical aspect of enzyme action is essential for insight into biological processes and application in biotechnology, medicine, and industry. Thank you.